choice behind you now. You can do anything. One voice, but you can sing. Don't change a thing. Embrace your fears and find their meaning. Time ends the suffering. A forgotten path, a newfound dream. Take comfort in the life you've made. These memories can't be erased. Grasp onto what you love, and you will find the strength to move on.
right, time to get started. Good morning, good afternoon, good evening. We are going to be taking a look at doing a little bit of reverse engineering today. We're going to take a look at what we've got on the Wordle and my Wordle sites, just see how they work, and see what makes them tick behind the scenes. We're gonna ruin something for people. Just getting set up here. So I'm curious as to what the back end actually is. That's one of the things I'm interested in. I suspect that this is fairly front end intensive. I suspect there's not a lot of back end stuff going on there. So we're gonna see. Let's see. Okay. Yeah, if I had to guess, I would say that this is almost all exclusively front end. We're gonna find out. Find out together. The desktop. The G in chatting falling into the... Let's take a look at that. Oh yeah, it does bleed in there a little bit. I should probably shrink that. Adjustment there. Programming. That's okay. Okay, we'll use a desktop recording one today. Anything off that's useful is a little bit off. I wonder what happened that I ended up breaking this. Fuck it, we'll do it live. Oh, this is not the one that I want. Voice meter is fickle. Very fickle. It's actually a colossal pain to get working properly. Yeah, it took a very long time for me to get it working correctly. As I have a number of different inputs. Like I have my music that's on one channel. I have my TeamSpeak or like any sort of voice chat stuff that's on another. And I have like my gaming or like regular computer audio going through a third. And depending on whether or not I'm using my speakers or my headphones, although I have to buy a new DAC because my speaker DAC broke, I'm able to kind of like route accordingly. But it was a huge pain to get up and running. Oh, here we are. put that layer at the bottom. There we are. Okay. Let's take a look at this. So let's start with Wordle, because that's the more popular one here. So this is what we're going to be looking at reverse engineering here. Just seeing a little bit of how it works. So I did download the source code for it. You can just take a very quick look at the HTML for it. Nothing special here. Some styling is right in the page. Gross, there's Google tags. And this is some sort of single page application. So there's just this game app tag here. I'm going to take a look here. Window.wordle. Finding the hash before the main bundle allows the bundle access window.hash. Okay. So this is going to be interesting here. So there's some sort of key potentially. That's good for us to keep in mind. Now we have to deobfuscate a boatload of code here. Now, do this with Python here. It's sent, exclamation point, Python. On.tool. No JSON object should be decoded. Okay. Oh, I probably said pretty print JSON. I want a pretty print JavaScript. I can make Chrome do this. I'm just curious how if there's a way for me to do it. Okay, so there's a Python library that I can use for this. Oh, there's a Node one as well. Okay. It is beautify, not beautifier. Okay. Okay, so that's one. Let's beautify this other one. Okay. Where do we begin here? So let's just at least see if we can figure out what language this is. There's some reference to copyright the Microsoft Corporation, so that's probably this block here, whatever this is. There's some game keyboard, so that's building out something there. Styling. User agent functionality. Okay, so we've got some templates defined here. Interesting, there's this reference to a countdown timer. Next Wordle. Maybe, oh, this is the countdown timer for when the next one's available. That's what that's for. Okay, and looking at this MS, language tags of some sort, guest distribution. So this OS kind of looks like this is your statistics information here. Game stats. Okay, so we can kind of see some of the building blocks of this. Some SVG stuff, so some icon of some sort in there. Now the interesting thing will be, can we find, is there like, one, we want to see if there's an API call of some sort. Is it getting the current word from some other place? Or is there a list of words that are built in that it is using? Let's see if we can at least track that down. See if we can see some of that. There is this reference. Okay, so there. Oh, this is clipboard. Okay, so this is probably like the share functionality right here. Okay, got a little bit there. Generator of some sort. I'm not sure what that generator is. Some styling. Hey, there's a Stack Overflow reference there. Hard mode. Okay. Reference to the hard mode. FBI, open up. Evaluate row. Okay, all right. Okay, so this is going to be an interesting reference here. So this does the okay, so this is going to be interesting. So we say void add toast not in word list. So this shows up if you enter an invalid word. So there's a word list contained somewhere. So there's TA and LA. Those are going to be interesting for us to look into. So we're going to want to track those down at some point. So that's going to be interesting to dive into there. So there's a capital TA and a capital LA that has some sort of list of, so E. Now E is being assigned here, and that is coming from S, and S is the board state for that row index. So there's this row index of what the current row is that you're on. And this board state is keeping track of, my guess is that this.board state is just going to be like a 1D array of like each word one at a time. That's going to be my guess. So we're going to want to check some of that stuff out. And you can kind of see there's this array 6 that's been hard-coded here. Here's the... Okay, so SS here is the list of responses when you do things successfully, or when you guess the Wordle. Some call out for fail. So I guess when you whiff. This looks like it's React. Looks like we've got some constants here for like the state of the game state. Cool. All right, take care, Glenn. Okay. All right, so there's a list of letters A to Z. That's defined in BA here, and we split this, and then there's a slice. This looks like... I'm not sure what G does. So I'd have to look into that G function. But splitting and slicing the first 13, that's probably like it reconcatenates them back together or something. But I think slice 13 takes like the first 13 items off of that. So it looks like this might be like rot 13 kind of looks like that. Okay. Here we are. A word list. How long is this list of words? What are we sitting on here? Okay. My computer, I can feel it chugging, trying to go through this. So, 20,000 characters long. Let me just do some math here. Because we have an idea of like how many words we're working with. And there's 2 lines here. So 2 0 8 5 2. Actually, technically 851. No, we'll do 852. Yeah, that's fine. And it starts at 19. Okay. Okay. So we've got 20,833 characters in between these. We've got 5 letters for the words themselves, 6, 7 for the quotes, comma is 8, the space is 9, but I have to add 1 onto the end of this in order to be able to work that out. So let's just divide that by 9. So 2,300 words in that list there. Notice that these are actually like different, like they're not in order. Now TA, on the other hand, is significantly longer. That is almost 5 times longer. That's 95,000 characters long. But this is this is, notice how these are all sorted. So I think this is like the list of potentially valid words. And I think TA and LA were ones that we had seen earlier. TA and LA were ones that we had seen earlier. So I think TA is the list of valid words, and I think LA is the list of ones that are guesses. So I know moist was one of them from a couple days ago. I think these are just the answers. So, okay. I said at the beginning of this that I was going to potentially ruin Wordle. Okay, so just a minute. Where was moist? What day was moist? I'm just looking through the list of... So, notice when we started looking at this was actually like compressed and obfuscated. So like this is not the original source code. Like they didn't make it this way. They probably ran it through like an uglifier or something like that compresses everything down to save space. So this isn't something that the devs did. I think this is... I think they just ran it through some sort of processor. Okay, it was February 2nd that was moist. Okay, so there's moist. We're on the 5th. I haven't done the Wordle today for the 5th, so I want to test something out. And I know that pleat came up. So 2nd, 3rd, 4th. Pleat was yesterday, I think. I'm pretty sure today's is aloft. So we're just going to try and one-shot it here. I said aloft, right? Yep, aloft. All right, are we gonna... Boom! So I've just broken Wordle. So there's just an incrementing list. We're still gonna try and figure out how it all works, though. And see why, or how it's able to pick that particular spot in the array and all that. I feel like I have to share this. Boom. Okay, so let's still go through the process of trying to figuring out how it's able to pick this list out. So we've at least identified like the two critical variables here. So LA and TA are providing those. IA, MA, OA, these look like statuses of some sort. Also, this is 100% like a Google tag code or something like that. A Google Tag Manager. Okay, so we've got LA here. So let's LA. Okay, so let's start renaming a few of these things here. So let's make sure that we, and we're gonna start changing some code in the process. So we're gonna just slap a semicolon onto the end of that, make this a little bit easier to work with. Bar, boom. Oh, no, my Vim's just having trouble. I break something. Okay, it's literally just having trouble with the formatting, I think. Okay. I notice there's this debug mode here. That's interesting. Debug mode. It's faster to write out not one than, or it's less characters write out not one than to write out false. I don't know why they didn't write out 0, but okay. Let's start with answers. So I had seen a couple articles when the system, or when there was the announcement that that Wordle got bought by the New York Times, and people were like, "Just download the page now, so you can continue playing it." So okay, so Aloft is 2,100 characters in. There is 20,000 characters worth of content here. So for the life of this game, it's only gone through 1/10 of its content. So what did they? 2 minus 17 divided by 9. So it's only gone through about 230 words. Ish, give or take. So there's like several years worth of content still left in this game. So yeah, downloading it and just running it locally is totally valid. Here we are, yeah. Oh yeah, duh, of course, it says 231. Herder. Actually it's my estimate was like right on there. Look at that. Okay, so we're 231 in. So how do we get the 231? I think is the next interesting thing here. Now I do have to unbreak the code at this point because I've renamed LA to answers. So we're gonna just work our way through all the code here and do that. There we are. TA and LI was one of the ones that I identified. Okay, we've caught all of those. TA, on the other hand, I believe that was the valid word list. Okay. Okay, so now we have to figure out how it's determining what today's current value is. I see there's this reference to May 19th, 2021. which I suspect is 231 days ago. Good old Wolfram Alpha. Except the month is the month 0 based? Is it one of those? Yeah, it's... JavaScript dates are weird. Let's just grab that. June, yeah, okay, it's 0 based, so. June 19th, 231 days. There we are. Okay, so we found the epoch, I guess. This is the Wordle Epoch. Why does it not want to like dent? No, this doesn't want to. Okay. And we're going to start redefining those. Okay, so there's only 2 references there. Okay. So there's this call to NA and GA here. The epoch is only used... Oh, epoch was one of the answers. Let's maybe call it starting date instead, just so we don't potentially run into issues there. Okay, so we've found that. We can see that NA calls that, and NA is right here on line 9. So it takes... If all the variables and methods were 5 letters, I would... Oh my god, that would be brutal. That'd be mean. That's a whole other level of trying to fuck with people. Now, interesting, this... I know there's a lot of, like, memory copying here so you don't clobber variables. But it's like, you're passing a date into a new date object, and that's, like, a little weird. But that's okay. It works. Okay, so it only references that. 864E5... that's like 864 with 5 zeros at the end, I assume. And 864,000 or 86,400 is the number of seconds in a day, I believe. So add 3 onto that, that's the number of milliseconds in a day. So this is doing like a date calculation here. So this is probably calculating the offset, I guess. Okay. So set hours is just like trimming the time down to nothing. So that's fine. Now A is being passed into this GA function. So we just need to trace that back. Let's rename this NA function first. Let's just see where else this is used. Okay, so it is used in a few areas. We are going to want to be a little bit careful of, let's just call it calculate offset. Okay. Now this does get used in a few areas. Let's trace back this GA function. See where that's going to use. I think this is like going to be the initial starting point here. Okay, so there's that day offset that gets evaluated here. I didn't define that. That must have been already like set in there. I see there's a reference there. Okay. Okay, so this actually, you know what? This will infinitely loop. So this DA is probably, you can see there's answers.length, which is what I set that to. but it's modulus this. So this will like keep going. And then with the 2,300 potential options there, it's just going to keep looping over itself. This is like calculating the offset from epoch. Again, we're just going to adjust those as required. Great. Now DA, where is DA used? Okay, so the solution, so DA grabs the solution itself. Get solution for for date. So this E looks like it's the current date. So calculate offset from epoch takes E. So that this is, so A is the current date. Or the offset date, I should say. Oops. Our A is going to be nothing. Bulls. Man, I hate when I realize that this is supposed to be obfuscated and it's supposed to be compressed code, but like multiple statements on the same line separated by a comma just like hurts my head. So this is not returning A, it's returning answers A, but it just happens to run the statement all at the same time. There's the offset date. We take the offset date, we pass it in. So A is really the index. So S is the offset. And then A is the offset within the modulus of the answer length. So this is, let's just call it offset modulus or offset mod. Okay. This is actually super clever. It's all self-contained. It's not that big. Like there's a lot of content in here, but it's compressed as much as possible. I don't know what this BA and FA is for. This is... We might just like run this outside and just see what happens. But this is kind of clever. Okay, so they've just said like, here's the starting date of June 19th, 2021. And every day you get a new one. We calculate a new offset based on that. Oh yeah, they did start on Juneteenth. Yeah. In a day. Okay. What else do we want to dive into here? Is S being assigned to the starting date? Okay, so the only reason why they reassign it here is because we go s.setHours here, and so while this does return a date, I believe it also overwrites the internal contents of it. So that's why they're doing the new variable assignment there. This G function is one that I'm interested in, though. I'm wondering what this, like, the BA and the FA is. So I think FA is it's going to be an array. It's probably going to be like an array of all of the letters or something, but I'm curious as to what that function is. Unfortunately, tracking down a single G. Actually, function G. Okay. Okay. So again, a little bit of obfuscation here. So it says return function, but it's actually executing the function at the end here, it looks like. Okay, so if the passed-in functionality or the passed-in variable is an array, we wanted to return f of e. And f is right here. Now, a is an optional second parameter. So if a is null or a is greater than the length of the e array, and okay. So if a is null or a is greater than the length of e, assign a the length of e. Or, okay, so s is the incrementer. Let's not be fucking evil here and assign it the letter I. Yeah, s is 0. Okay, so we can... Who sets their incrementers to a variable other than I? I guess obfuscators do. Now, t is a new array of length a, so it's the same length as e here. And then the result, okay, so t is the result. So let's just call it this. So I is greater than the length of, we should be copying here. E is our input array. Okay, so this is just like, this is an array copy of some sort. Well, thank you. Yeah, I don't think in English, I think in code. Oh, we broke Wordle. We broke Wordle. I did 1 out of 6 it. So I'm gonna given that I've essentially like I know what all the upcoming ones are going to be. I am gonna avoid that section, but I'll say that we found 2 lists of words. One of them is here are the answers for every single day. There is 2,315 possible options, and it loops over once it gets to the end. So 6.3 years worth of content out of this before there's a repeat. We also found a list of it was like 90,000 characters long, so about 10,000 words, which are the when it says, oh, this word is not recognized, that's the list that it's coming from. So based on what we've seen here, there is, where are we here? Oh, I've lost my place. Answers, here we are. Okay, so you can see that some of these are the starting ones, and we found the valid words here. No, you got to work for it. You got to work for it. I'm only I did a proof of concept to be like, have I actually like figured out the order of this and does this make sense? Yes. But after that, I'm not gonna use it to cheat. But it was interesting to look into nonetheless. Okay, so yeah, we found the starting date. So it was June 19th. So it was Juneteenth, 2021 that this was first started. JavaScript is weird where it 0 bases the month for whatever reason. I don't know why. I hate that portion of JavaScript. Indeed. Yeah, great power comes great responsibility. So what this starting date does is it feeds into essentially this function here, which I renamed to get solution for date. And so it calculates the number of days since that epoch and then just grabs the word that's there in the list. But it has also prepared for the fact that, hey, at some point we're going to burn through all 2,315 potential answers. And so it will start all over again at that point. And it just loops. So that's where this this offset mod comes into place. So it calculates the number of days since June 19th, 2021. Then takes the number of answers in the list and will, if you go over that, so let's say we've got, so 2,315, it will say, okay, we've hit 2,316. Well, subtract 2,315 off of it. Now we're back at index 1. And then it pulls that list, pulls the, this is not the 0th, but the first out of the, or the 1th, I guess, out of the list. So there's a few other things here that actually, like, I don't fully understand why they would do things in a certain way. I think it's like deliberate obfuscation of some stuff. Like this is like literally just an inefficient way of taking this list of all the characters from A to Z and putting them into an array. I don't know why it was done this way. Some sort of obfuscation in place. But you can see that this is the logic for storing statistics. So you, like, how many times did you get in the first try? How many times you get in the second try, third try, fourth try? And so this is like the default state, which would then get loaded into your browser's local storage. So this XA function looks like it was used for reading the contents of, so let's call this get statistics. Let's start renaming some of these. There we are. Okay. So YA is the key for how this is all stored. It's using local storage, not cookies, but same general concept. Except cookies you can would go with HTTP requests back and forth to the server. This is stored entirely on your local machine. So yeah, same general idea, it just doesn't hit the server ever. So YA is statistics key. Yeah, I think, like, given that this was like a pet project for some guy for his wife, he very clearly wrote this to be like, no, this is just for like somebody to use, and wasn't trying to monetize it, wasn't trying to gather statistics or turn it into a big data project. Oops. There we are. Okay. Okay, so we have so this is just going, okay, let's see if we can retrieve the item, the statistics from local storage, or if we don't have it, take the default version. Local storage only works in strings, and so it assumes that it's going to be a string version, and then it just parses it to JSON afterwards, so there's a format to work with there. Now, VA does look like there is... This looks like how it would save things back. So you can see the local storage reference here again. It's setting the statistics back. Let's just see if where else local storage is used here. So they do have a few things here that are tracking local storage. So like your settings. So are you using dark mode? Which, God forbid you're not, and you like looking at the sun. Or whether or not you want the colorblind theme. That's kind of interesting. So those are all things that are tracked on your local machine. There's a ZA here, which takes... Okay, so this stores the current game state. Or this gets the current game state. So let's update this. There we are. Boom. Boom. Okay. So WA. Here. Game state key. So not function local storage dot set item. So VA. Okay, so this function essentially says here, okay, A is we're going to get the game state. So if you are partway through the current days, let's just open up incognito mode here. So let's say, oh, I want to come back to this later. So I navigate somewhere else. I come back. Oops. There we are. So it is able to, it remembers that state. So that's what we were looking at there, is this get game state. Now, this looks like it updates the game state here, because we can see the game state key is in use. And so A is the original game state. Now, this looks like, so this is like the new game state, is E. So JA is probably like update game state of some sort. I see that's used there. Last completed timestamp. Okay, so it looks like that VA method is probably doing some sort of like merging of the data into one thing. Yeah, so let's just call this update game state. I don't need to worry about that. Not sure what that line is for. Okay, so you've defined that. That's good. What else is there for us to break in this? I think we've largely figured out like behind the scenes how this thing works. Like we've figured out how the statistics get tracked, roughly speaking. We know how the current day's word is picked. We know how it calculates whether or not the word is valid or not. Or at least we found kind of the entry point for that. Answers. So here's so this evaluate row is what's driving it. And you can see the not in word list thing there if it's not there. So then it's doing some math here that part of me doesn't want to go through this, but like, I mean, this is not, yeah, you know what, I'm not going to go through this. But this is essentially looking at this and going, okay, I have the answer. So I don't care about this being hard mode right now. Let's skip over hard mode. Var equals function, so we evaluated immediately. So this is actually doing the work here of this dot solution is A. So let's rename A here. Okay. Now E is probably what was, so E is what is passed in here as S. Now S is probably what was, yeah, okay, so S is the proposed answer. This is what was written in. Don't need to rename that one. I do need to rename that one though. And we pass in the proposed answer there. We're gonna rename that just so we can. Okay. Yeah, so this R function, which there really is no reason to name it because we're executing it immediately, and I think we're throwing it away afterwards. Yeah, there's no reason for us to. This is just a way of obfuscating this, and I'm not sure, or to like encapsulate it. But we could have that as an anonymous function. That's okay. Okay. Okay, so we say this function executes and takes the proposed answer and the true solution. There's some sort of for loop here that works off of this n iterator, which goes from 0 to the length of the proposed answer. So it's going like 0, 1, 2, 3, 4. And then it's doing some calculations as to like what it should be putting in there. So what is OA? This is going to be like absent. Okay. Oops. Just going to rename that. Yes, I do want to change that. Ah, there's the, I guess this is, oh, this logic here that we're looking at is generating the board state when you click the share button. So, is it normally like green, yellow, and black? So this is like light mode versus dark mode or something like that. I've never seen the blue, or is it colorblind mode maybe? So what's this R function? Local storage.get item of J. What is J? Okay, J is the marker for the dark theme. Don't care about that. We do care about that. Okay, so this variable R is dark mode. Okay, no, I is used for something else. So I is probably colorblind mode, I guess. Yep, there we are. Colorblind theme. Very smart. Is colorblind. Oh. So if you have, so that's actually kind of interesting. So if we looked at, okay, we've got some examples here to work with. So this one will have the loft for today. Okay. So if we wanted to share this, depending on whether or not we were in colorblind mode or not, it would share differently. So if I flipped on, let's just turn off the dark theme for a moment. And okay, so that gives us the light squares. I know, I'm sorry. we'll flip it back to dark theme. So we've seen that, and we'll turn on colorblind mode. And so you can see that the colors there are different. And if we share that, the values we share as well are also going to be different. So you can see they went blue and orange, which aligns with what we had here. So this logic here that it's looping through is looking at each of the steps that you had. Yeah, you know what? The colorblind theme is pretty nice. But yeah, depending if you loop, it loops through each of the tries that you had, and then builds out each one of the rows. So there's these 2 nested for each loops here, which is kind of neat. And this is clever. E and E.for each is a way of saying only run this loop if the entry in this particular row is non-null. It's very clever. Very clever. There's the day offset, which is used for like Wordle 231 for example. Oh, it tracks whether or not it's hard mode and whether or not you won. Oh, that's clever. That's very smart. Okay, we've broken this game. Let's move on to the My Wordle one, because I think that one's also interesting. I did a little bit of work on that one earlier, but we're going to start from scratch on it. I don't know how I opened all of that stuff. That's weird. This My Wordle one was one that people had circulated. And so this one is kind of interesting because it's like the answer has to be there. You just need to figure out how to kind of sufficiently obfuscate it. So if I just do A. That's really interesting. So that kind of breaks things a little bit. Oh, that's actually super funny. Coffee link. That's so funny. Okay, I know why it does that. And I'll talk about how I would solve that in a moment. That's hilarious. Okay. So either way, so this kind of tells us something immediately off the hop. It means that the word that it shows here, the number of characters is the same as what we put in. So I put in like 5 characters or 6 or 12. I got 12 characters in the word listed here. So that's good. So it means that we're working with a finite length. It also means that there's some sort of translation that's happening, and there's a key that's being used and the key that's being used is the word Wordle, and it's just being like repeated over and over again. So that's giving us some clues already before we even look at the code itself. So let's save that. What's the domain for this? mywordle.strivemath.com. It is the Peach Edition Red Bull. Very good. Okay. Let's dive in here. Again, we'll start with the index. Just take a look at what's here. Oh, people not formatting their stuff. Okay, we do see that there's a div ID root that's referenced there. There's a no script tag here. Some stuff that's included. There's a main JavaScript thing that we're going to want to look into. I do drink energy drinks sometimes. It's not often, but I do if I have them in the house. I'm more of like a tea and coffee person now. They're, I will say they're better for you. I won't say they're good for you, but they're better for you. Okay, so there's not really much to see in the HTML here. This is nice and basic. We're going to see a reference to this root with nothing else here. So the fact that there's no content in here means that we're working with some sort of single page application framework again. I think I saw that it was React looking, but we're going to find out for sure here. It's at least heavily obfuscated and has some sort of templating engine in place. If it was Angular, we would see like a vendor.js and a main.js and entry point and like a few other things. So this feels React-y. So let's take a look at that, that main.js. Boom, all right. Let's take a look here. Okay, so a bunch of functions that have been declared, references with numbers, gross. I guess so. Let's just see if we see anything. This looks like a bunch of like boilerplate stuff. These look like polyfills. This is supporting various versions of browsers that don't have functions available, so they're polyfilling this stuff in. Generator is already running. This looks... Yeah, this all looks like boilerplate stuff that is required in order to get stuff functioning. SVG filter, I don't think we have to care about that. This is all... Don't care about any of this, I don't think. Okay, so we see a few things here that are like actual code. We see some references to styling, whether or not you're in a dark or light theme. Is there a dark or light theme? Let's see what we got here. There is a dark and a light theme. Okay. Here's why the URL changed. Okay. Okay, so we've at least we see some application specific code here. It's not going to drive anything with it, but at least like is telling us that we're starting to hit some application code. Yeah, again, a bunch of stuff that we don't care about. Requesting an animation frame of some sort. Okay, so there's some animation that might be happening there. Okay, some date calculation of some sort. Do we care about that? Maybe, maybe not. Previous sibling, next sibling. See, we don't think we care about... Again, this looks more like boilerplate stuff. Okay. Let's see if we see anything else here. Looks like some sort of URL generator here. There's references to ports and path names and hosts. It starts with a data tag here. So it does look like there's a little bit of maybe that like the share button ties into that. Or maybe this is just like code injection stuff again. Okay, so here we're starting to do some like math. This might be something that we're going to want to dissect a little bit later. There's not enough information there for us to work off of yet. Dividing by 255, this might be like RGB stuff. 5 is like a notable number, and we do see some references with a hashtag and math.round with the 255. So there might be something there that is color based. HSL, HSLA, yeah, these are all things like that. How far? We're only 7% of the way through the code. Okay, we might still be in like boilerplate code area. Yeah, there's no way that we're using all of these colors here. Okay, so we're still looking at boilerplate code. We don't care about any of this, hopefully. Canvas stuff. I don't think there's any canvas stuff in here. Okay, so this is pushing some styling into the page, it looks like. It's doing some translation of colors here to define... Okay, so... Okay, maybe let's take a different approach to this. I was hoping that we would find something like nice and juicy just by scrolling through here. But I'm not seeing anything that like particularly stands out. But I have a different approach that we can take here. Although this does look like we're starting to get into some of the... Maybe some of the code, I don't know. Okay. What we can take a look at here is kind of like the main. So if we grab that previous link that we were looking at here, we slap that in. So this is interesting. So we've got a URL here and it's got this word keyword here and it's taking a value and it's doing something based on that. So that gives us something to work off of. So if we can track down this search parameter here, we can get a little bit more information. So document.location.search gives us like $word equals Wordle. Now I think you can, there's a way of parsing this, but we at least know that there's this word keyword, which is going to be important. We're going to want to track down the source of that. So how bad is it if I just search for word in this? Word spacing, password, Wordle, okay. Wordle, we don't care. So that's Webpack stuff. So this was definitely compressed with Webpack. Sword was a word, wordy was a word, words, worded. Okay, so we've got a bunch of like known words there that it's working off of. Okay, here we are. Here, this is interesting. Hey, Jordan, how you doing? How you doing? You missed us essentially completely breaking how Wordle works. I won out of 6th today's Wordle because I was like, well, if that was yesterday's, then this one must be today's, and yeah, 1 out of 6 did. So I didn't look any further in the list, but it's kind of interesting how the system works. Well, I look there's a list of words that are there, and there's just an array, and there's this date offset that calculates. So if you know, well, don't go looking. I'm not going to tell you what the date is. Oh yeah, it's still great. And this is not the Wordle site. We're now onto my Wordle instead. But yeah, there's just a list of the answers there. There's 2,315. And it just like works its way along the array based on the date offset. Yeah, but yeah, if you see the if you can get the list of answers and you know what the offset is in the starting date, then it just works its way along. And if it hits the end, it just like it's like mod the list and it just jumps back to the beginning. So neat way of doing it. There's also another very long list of like 10,000 like known words. So it's interesting to see how it works. Now my Wordle is much more interesting because you can generate your own. And one of the things that kind of like tipped me off that something was a little off here is if you just kind of go A or something like that, you generate a link. So it does some encoding here. So there's some like, I'm gonna hesitantly use the word synchronous or symmetric encryption, and I'm using it with a very big grain of salt. It's encoded in some way, but WORDL, something's a little suspect there. 1, 2, 3, 4, 5, 6, maybe. Wordle. Okay, so like the initialization vector of whatever they're using to encode it is the word Wordle. That's useful information for us. The other thing that's useful to know is we've got this search parameter there. So that search parameter of word is going to be important for us to work off of. And I think we did find where the decryption takes place. Because we do see this location.search, which is going to be useful. And that's what we were keying off of when we were in the browser. So let's take a look at this. Okay, we actually see the word Wordle right there. So there's definitely something going on with that. So let's see if location.search is used anywhere else. I do see location.search.lang is there. And there's this te.parse. So te is something. Takes R of 172. So there's some sort of R of 172. So R is a... Okay, so te is a function because it's some sort of object that has functions attached to it. And R of 172. So 172 is a reference to something. Probably this. So this, whatever we're in here right now, is probably something that has to do with that. And so, dear God, okay. So 172 is some sort of function that looks like it is decoding the search string, which seems to be this. I kind of don't want to go into it because I think I can pretty safely work under the assumption just by looking at this that te.parse is doing the parsing of URL stuff. So this is some sort of like URL helper. So let's just rename that now. Yeah, this exists in a lot of areas here. Here's this te function. Do we care about this? I'm not sure if well, I'm just renaming it in the area. I don't know if I care about these ones. The problem here is just like understanding where the scope and begins, but that's okay. We're gonna essentially take what the areas are that we think are the encryption and decryption areas, and we're just gonna extract them out into their own document. We're just gonna run them locally here until we can put them into a parsable format. We can actually understand what they're doing. Okay. Okay, here's our URL helper. We've defined this. We found this me function. This is looking pretty tasty. So I think this is where we're gonna wanna extract this method out. Now, where else is using location.search? Actually, we don't care about that. Let's grab this here. Because I see the word Wordle here. I see string character codes in use. 122 is the character code for a lowercase z. That's like the end of all the characters. So this is looking like an option for us to work with. Okay, let's just... Okay. Oh, computer's struggling. All right. Like that, we're just gonna slap that in there. So we're definitely gonna need to clean some of that up. It's not gonna work on its own. We also don't care about parsing the location.search. We can just pass some stuff in, but it gives us something to work off of. Now for the URL building, something is getting word equals, so we can try and track that down maybe. and see if we can find the other portion of this. Ooh, there we are. Okay. So there's only two places in this where word equals exists. So A is the value of A is the encrypted, encoded version, and it's being generated by this Q function here. And so I is the input in this case, so that's the decoded version. So, oops. Let's see if we can find that Q function. What is that? Does this have... Okay, this looks, again, promising here. So again, we're seeing some of the same logic here. We're seeing the word Wordle here with this variable O. We're seeing references to upper and lowercase, which was there before. Some modulus work, 26 letters in the alphabet. 97 is the starting... I think that's a lowercase a. Maybe. I think it's around that. But this Q function, I think, is our encoder. Okay. Okay, so let's assume that we have like successfully extracted those and oops. There we are. Okay. We have a few things to work off of here, and let's get some test functions in place here. So we want to change this to accept an input, and location.search.word. This is the input itself. Let's just slap that in there so we've got a... can actually interact with it. I think everything else there is probably safe. Let's build... Okay, so let's just build a little quick test harness for us to work with here. So we're going to generate some test data, and we're going to run them one after the other and just see what gets outputted. So let's go E and D just to make this a little bit shorter. Generated... okay, we should be able to decode that. So we want to check first we have E, D, we want to just spit out there. And E equals encoded, E equals coded. It should be triple equals. Okay. Be a good JavaScript developer. That should be sufficient for the test. So test. We get an encoded version of Wordle. And the inputted version was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I may have broken something already. Okay. The encoded version, you need to make it all caps. That's interesting. It did act a little different. Okay, let's just... We don't care about the case, so let's... There we are. Okay. So we've got a little test harness built there. Let's generate a few others here to work with. Puddle. Liugwi. I saw the word fun in chat. We're going to use the word fun. B-I-E. Okay, so we've at least confirmed that we're not breaking anything in the process of this. Everything is returning true. So let's dive into this and see what it is doing. First, let's start with the encode, because that's a little bit easier to probably get our heads around. So we're going to change the variable e to input. Let's make it easier to think about. Okay. So let's just take a look at this first line. So we have a for loop that we're going through here. So we're creating an A variable, we're creating an R, we're assigning S to an empty string. O is some sort of, again, initialization vector for this encoding of some sort. There's our I incrementer. N is some sort of incrementer as well, but we at least, the lack of word wrap is probably letting us see where it is actually incremented. We do see a reference to N being used here. So N at least is in use within this, but we don't really know what its purpose is. So let's just start moving some of these variables out into, so we can start assigning values to them. RO equals Wordle. We're going to call this E. Okay, so we do see a plus plus N there, so there is some sort of adjustment that is happening to N. That is it for the key as far as this. S, we can see that S is returned, so S is going to be our result. And let's just rename that to result then. Okay. Now A and R. R is assigned to the value of T here, so why it needs to be pulled out, not sure. Maybe it's just more efficient from a memory perspective. So input.character at, so input.length, we're iterating over the input that we provide from the 0th index to the end. We increment with each loop here. So this is just grabbing the character we're currently on. That gets stored in T. So let's just start renaming T here. Result plus equals current character. So we're doing some translation potentially there with it. We say 1 equals current character dot length. So this is just a obfuscated way of saying true, I think. So R equals is a singular equal, so it's an assignment, so there's not a comparison. We're only working with one character, right? So this should be... I'm pretty sure that statement is true. It's always true, unless there's like literally a multi-threaded race condition and the input technically changes in between this iteration happening of the for loop and the character at being old, and you get a null. But I think that would throw an exception. Okay. So this is actually interesting. There's this check here says r.match A to Z with a case insensitive. There's no reason to have both of those in there if you're doing a case insensitive match, but whatever. But this r.match is just saying, are we working with an alpha character rather than a numeric one? So does this take... It doesn't actually accept numeric inputs, so I'm hitting like 1 right now and it's not taking anything. So this is another way of just saying true. Now I do see question marks in here, which means that there's ternary operators in place. Ternary operators really shouldn't be used in in readable code. You would never use a ternary operator in this because it's too easy to lose where everything is. You would normally just do like if-else statements for them. But hey, they were trying to compress, this code was compressed. It was run through like Uglifier or something. And they wanted to deliberately obfuscate it, it looks like. So let's just start with some formatting here. So we have question mark here. There's nested ternary operators. Oh, why would somebody do this? This is mean. Okay. I mean, it's obfuscated, so, I mean, no surprise. Okay, so let's start by just making these into if-else statements. So if that happens, so then that is the first step of that. This is now starting a... Okay, we can delete that. And this is the else portion of that, I guess, else statement. But this section, this second statement here, this n incrementer, needs to sit outside of this because this comma is not part of that ternary operator. Okay. That's one level of the ternary operator broken down. So let's break down this other level here. And then we'll worry about cleaning up some of this code to understand what it actually does. That is there. Okay, so that's gotten rid of the ternary operator, so that makes things a little bit easier to process here and trying to figure out what's going on. Okay, so we say 1 equals r dot equals current character dot length, or assign current character to r dot length. So this is going to return the value of r in that case, which is current character, which is a single character, because we pulled, excuse me, we pulled that from input.charat. This has to, by definition, only return a single character. This has to be true, this first statement. So we can literally just remove it. So we're saying if true and something else. So we don't need that. Ooh. Now, we did also confirm that we can't actually input numerical values. So r.match, I guess technically this would have been assigned to r, so I guess we need to... r is only used as part of this particular operation, so we can actually just swap this out for... Come on, here. Current character. We can actually just delete this whole thing. Let's just run that really quickly. Everything is true across the board there. Tests are still good. So current character.match an alpha character, which we've already confirmed by definition is the case. So that also returns true, which means that this else statement goes away as a result of it. So let's make that whole thing. So that was literally dead code that was put in. Okay. A equals current character. So if A is uppercase, or I'm not sure what this A to lowercase comma 0 does. Let's just open up an interpreter here. Okay, we've assigned two variables, lower and upper, just for lowercase a and uppercase a. Oh. So lower comma 0 equals 0. Sure. Upper comma 0 equals 0. So this seems like a really fancy way of just saying 0. I guess there's some function play that's happening there. That seems like a JavaScriptism. But no matter what I put in here, whether or not it's lowercase or uppercase, you're saying it's 0 always returns 0, and 0 is false. So a dot lowercase to 0 that's just false. This is saying literally or false. We can get rid of that. Now our input, we're passing these in as lowercase. So that's interesting. So if we generate this link and I copy this and we go to this page, so we know that this word is fun. But if we change these to uppercase, oh, I'm assuming I've got local storage, which is, yeah. Oh, it's keeping all the stats in the back here, so we just get rid of that. So, okay, so it still thinks it's fun behind the scenes. So it must be doing like a 2 lowercase or something. So at least functionally within this, it doesn't care about the case sensitivity of that. So that means that no matter what, A would be coming into this as lowercase, which means that that will always be false as well. So this line doesn't run at all. We're down to one line here. Okay. I think. Let's just run this and confirm. Trues across the board. Okay. You know what? This might come into play. What if we didn't do this encoding here? We did the lowercase and uppercase comparison afterwards. okay, so those are true at that point. So it might run through some of this logic here, just like the 130 and 194. We're gonna double check those. These offsets are speaking to me, so we're gonna check the Ascii table in a second here. But these look like they are 97, I think, is like capital A or lowercase a or something like that. I think that sounds familiar. And this, yeah, so this is probably 97 is probably upper, or 97 is lowercase a, 65 is uppercase a. So we're doing some slightly different logic here, just to the offset calculation for ASCII codes, it looks like. Now 194 is roughly 100 difference. So what's the... That's interesting. So, okay, we're going to want to take a look at that as well a little. Let's take a look at the Ascii table and see if we can draw some parallels here. Okay. 197 is in the extended codes there. We do see 122 and a 97. So the 97 was in there. That's the lowercase a. I've been coming to this site, this AsciiTable.com, for like literally over like 2 decades at this point. I want to say. So 97. So that's the lowercase a. 194. I'm not sure what the rationale for that number is. But we're doing modulus 26, which means that we're decoding it down to 26 characters in the alphabet. 65, let's see where 65 sits. 65 is uppercase A, so we have 65 and 97. So those are uppercase versus lowercase handling, and they go to 90 and 122, respectively. Hey, I see a 90 up there. I see a 122 up there, so it looks like those are definitely references used in the decode function. So we don't actually care about this being... this is just a fancy way of saying uppercase versus lowercase handling. So let's just say if is uppercase. But you don't want to change the value. So why 130? Let's just break out a few of these things here. Now I see a 25 in the decode function up there as well. So that's going to be like 26 minus 1, so where there's some offset calculation happening there. But we do see the 26 as well that's coming into play. In fact, we're just going to EC26, replace it with alpha count. Oh. Clean that up a little bit. Okay, so this is saying get the current character code here. We're just going to extract this variable out here. Okay, so key.toUppercase.charcode at n. So here's our incrementer of the n. So this seems to be like, and we saw this when we put in all A's. A was going WORDLE each time, so we know that the same character is... depending on what position it is, based on the key, we know that that is the outputted version is going to be different as a result of it. So there's a little bit of hidden logic there. Now string.to character code, so minus 130, minus 194. Oh, 130 is double 65. 194 is double 97. So it's because we're adding the numbers up and they're subtracting it. So this is oh, okay. All right. So we're figuring out stringed up from character code. So we're getting a double check the documentation from car. Oh, doesn't provide it. That's lame. String dot from char code. Okay. Okay, so string.from char code takes a arbitrary number of inputs and it takes the ASCII character code and generates the actual character and just concatenates them one after the other. UTF-16, okay, so we got 65,000 there. Takes hex, okay. There's 65, 66, 67, ABC, okay. Okay, so that makes a little bit of sense here. So string.from character code is taking so it's essentially doing some sort of like offset. It's essentially adding the two characters together. So we could actually do this like by hand here if we wanted. So let's say that we took, let's take A, spin up another buffer here. Here we are, okay. So let's say we've got A is our input. Wordle is our initialization vector. So we're taking A plus W. That's the first step there. So that's the character code. So we've got A, the key, we're taking W, and we're going to subtract 130. So we've got, and let's just assume that we're working with the uppercase versions. So we've got A, which is 65, W is 87. So 65 plus 87 gives us 152. 152 minus 130 gives us 22. We mod that by 26, so 22 mod 26 is still 22. And then we take 65. We add on to that. So plus 65. Oops, is 87. And 87 happens to be W. So that's why when you type in all A's, you just get the key out of it. And that's because there's that offset of A. Now, let's just take another example here. So let's just make it L. Something a little bit more spread out. So L plus W, we've got 76 plus 87. Minus 130, again, 2 times the 65. 33 mod 26, just going to subtract it, gives us 7. We're going to add 65 to that, which gives us 72. 72 is an H. So if we have, so I said L was going to be the first one, we get an H out of it. Okay, so we figured out how that offset is taking place. So it's literally just like summing the two characters up together and then scrolling through the list of characters until it finds the next one that's there. And it's going to do something similar for the reverse. So it's going to probably, I'm just trying to do the math in my head of how this would actually work. I mean, you can still do like negative number modulus. So it's going to take the encoded value, subtract. So we got, what did we get out of this? H. So let's see if we can reverse this then. So reversing it, we had an H. So we want to add, we'll work in the uppercase scope here for now. So we add 2 times 65. So that's the start. So we're going to add 130 to this. We then subtract the value of our character for our key, which is the 87. That gives us 115. Now we modulus 26 this. Oops. That's 26. 11. Then plus 65 gives us 76, which is our L. There we are. We have, you've kind of cracked the code there. And so for each time you put a character into the system, it's just going to increment along that key over time. So we could change this Wordle key to be something else if we wanted to. But it needs to be kind of consistent for everyone so that you have the same encryption decryption. I figured out how it works. That's very interesting. So if I was to like change this in some way, so to make it like a little bit, because one of the problems here is like if you know what the offset calculation is, or if you just like spam a character, it's not like someone could put in all A's fairly trivially and just go, oh, well, there's the key that like decrypts all of this. Not that they're going to do that because people aren't going to look into this. But like I would probably do something to try and obfuscate that key a little bit. So I would like build some memory into it in some way. So I would have kept track of like what the previous value was, and use that as part of the calculation so you can feed the system back in on itself. Because otherwise you're prone to attacks like putting in the same character all the time and seeing how things change, or if you get repeats. And it's a little bit easier to hide that if you are feeding the system back in on itself. It does make decryption a little, or the decoding of it a little bit harder. But like hash mechanisms, as an example, feed back in on themselves. The calculations tend to loop back in, so they're feeding their own data in. Cool. Crack that code. All right. Well, we've discovered a little bit about how those systems work. Very neat. Okay. Well, I think that's where I'm going to call this portion of the stream for today. I am going to be streaming later tonight because I missed yesterday. I have another day that I need to make up, so this is technically yesterday's stream. But we reverse engineered the official Wordle website. We reverse engineered the My Wordle version of it as well. And that was an interesting spelunking through the code. So later tonight, Dark Souls is I'm not sure whether or not I'm going to do Dark Souls tonight. We'll see. If I don't do Dark Souls, I'm going to pull out Celeste. Celeste is like a little bit less like stress inducing. But yeah, like if I don't do Dark Souls, I'm going to do Celeste, I think. So that's going to be, yeah, I think that's going to be fun. That's the plan, is one of the two of them. I'm leaning more towards Celeste today, I think. No, it's, you know, just a little bit lighter. It's the weekend, you know. I guess we'll see what other people are doing. Maybe maybe more people feel like pulling out the popcorn or something. So we shall see. But one of the two. But you know, I know there's a lot of people that liked watching me play Dark Souls. So if they happen to be available, I'll pull out the Dark Souls. But otherwise, if not, I'll pull out the Celeste. So either way, we'll get a little bit of like a challenging game nonetheless. But yeah, I'm going to be starting that in, I guess, about 5.5 hours. So it'll be 6:30 p.m. CT. And yeah, that'll be fun. We'll see how we survive it. So cool. All right, with that, I'm going to call this morning portion of the stream, and we will talk to you all later today. Adios.